Hello. 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 Where are you? This is Smith.
Okay, so Thatcher, this section starts out with theorem 10.14. When you're looking at segments of chords, so remember a chord starts and ends on a circle, okay? So this is going to be what you'll do for problems like numbers 1, 2, and 3 on your worksheet. When you look at this theorem, it states that if two chords intersect inside of a circle, then the product means multiply, right? Then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So that means part of one chord times the other part of that same chord, EA times EB, is equal to part of the other chord times the rest of that chord, okay? Does that make sense? So here's an example of that. You have this circle is divided up by these chords, okay? Chord KJ has X and X plus 4 as the segments. So if you take the two parts of them and multiply them together, you have X times X plus 4 that you'll see here, okay? And then the other chord is X plus 2 and X plus 1. So that is what's written here. You have to multiply the two parts of the two chords times each other, set them equal, and then you can solve for x. So here you distribute the x in. You have x times x is x squared, and then x times 4 is 4x. Now on the other side of the equal sign, we have to FOIL, okay? So you're going to have to say x times x for the first, and then the outside is x times 2, inside is 1 times x, and the last is 1 times 2. All of that will give you this step. You still with me? So hold on for number 4, Lily. Let me get to that page in the book, okay? So number 4 is going to use this theorem, the segments of secants theorem, okay? Now, what that says is if two secant segments share the same endpoint outside of a circle, then the product of the lengths of one secant segment and the external segment equals the product of the lengths of the other one, okay? So that's all in math speak. So now let's talk about it in ways that you can understand better. We know that these two are secants, right? Because they go into the circle, through the circle, they touch it twice. They meet at a common external point, and this is just like number 4. You see where it meets at a common external point? So what this says is that the outside part times the whole thing is equal to the outside part of the other segment times the whole thing, okay? So if you look at this example here that's on the screen, the outside part of PR is here at 4. And then the whole length is 9. Do you see that? So then on the other one, on RT, your outside part is 3. And your whole length now on that one is going to be 3 plus x, okay? So you take the outside part times the whole thing. So you have the outside part is 4 times the whole thing is 5 plus 4. and set that equal to the outside part of the other one times the whole thing. So the outside part is 3, and the whole thing is x plus 3. And then you just do your multiplication and solve for x. Does that make sense for number 4? Okay. So Thatcher, that's how you do 4, 5, and 6. Charlotte Ann, 13 is like number 15, but you don't have to do the quadratic formula for that. Is that what you were asking? No, you don't have to do the quadratic formula for it. And then give me a minute and I'll get to 18, okay? We'll talk about it. So, Thatcher, here's how the rest of the questions are going to be. They're going to use this theorem, 10.16, where you have segments of a secant and a tangent. So remember, a tangent touches the circle at one point and a secant goes through it and touches it twice. So in that last theorem we talked about, we had the outside part times the length of the whole thing and set that equal to the outside part times the length of the whole thing for the other secant. So this one, your tangent doesn't have like an inside part that you would have to add together to get the whole thing. It just has the outside part. So really it's still the outside part times the whole thing, because the outside part would be this part and the whole thing would also be this part. Does that make sense? So that's why it's the tangent squared. And then the other side of the equal sign is going to be the outside part times the length of the whole thing again. So this is where, okay, so look, we've got, on this one, you can see that we have a tangent and a secant. Remember, a tangent only touches the circle at one point, right? So the secant touches the circle at 2 points. So it has kind of two parts. It has, so on this picture for theorem 10.16, that bottom part is the secant, right? Where EC is your outside part and CD is the part that's inside the circle, where the whole length of that secant is ED, okay? Now, with the last theorem that we talked about, we said you have to set the outside part times the whole length of the secant equal to the outside part times the whole length. On this one, it's still kind of the same thing. We're just dealing with a tangent that doesn't have an inside part like this. The tangent is this blue line here, EA. It only has that outside part. So if we're going to do what we were doing is the outside part times the whole thing, well, the outside part of a tangent is the whole length, okay? Does that make sense? So that's why we're doing the tangent squared, okay? So you take EA squared, or the length of that tangent squared, and then set that equal to the outside part of your secant, which is EC, times the length of the whole thing, which is ED. Does that make sense? Okay, so now look down at example 3. Your tangent is 16. So that's going to be 16 squared. And then your outside part of your secant is x. And the whole thing, the whole length, is x plus 8. Okay, you see it? So then when we actually go through and do that multiplication, we're going to have to distribute this x in here to both of those terms. So you're going to have x squared plus 8x, and then 16 squared is 256. So ultimately we're having to solve for x, okay? And in order to do that, we're going to have to factor this. So if we move this 256 over by subtracting 256 from both sides, we end up with this, x squared plus 8x minus 256. And you guys, all of you that are on here, this is an example of how you're going to be able to do number 15 and 18. No, maybe not 18. It's an example of how you're going to do the ones that have the quadratic formula. Okay. So when you're doing the quadratic formula, or when you get to this part where it's x squared plus 8x minus 256, you need to try to unfoil that, okay, where you can break it out into the parentheses like that and say x plus something times x plus something, and that would be what gives you the x squared plus 8x minus 256. But these are yucky numbers. They're not easy to try to figure out how to factor them. Okay, you can't just look at it and say, oh yeah, immediately I know what goes into that. So plugging into the quadratic formula is going to be easier, even though it doesn't look easier. So quadratic formula, I had you guys write it down yesterday, was negative b plus or minus the square root of b squared minus 4ac all over 2a. And that equals x. Okay? Everybody have that on their paper? So now, when we're in this form, x squared plus 8x minus 256, the number in front of your x squared, or the coefficient of that, is your a. So our a on that problem is 1. The number in front of the x is your b. So our b on this problem is 8. And then the number that's out here by itself is your c. So our c in this one is negative 256. Okay? Everybody remembering this? Is it coming back to you? So now we're just going to plug into that formula, okay? So negative b, the negative is in the formula. Our b is 8, so we're going to actually have negative 8, okay? And then it's going to be plus or minus the square root of, b is 8, so that's 8 squared, minus 4, that's in the formula, times a. Our a is 1, so 4 times 1 times c, and our c is negative 256. Okay? And then that's all over, or all divided by 2 times a, which is 1. And now you're going to calculate that. The video that I posted on Google Classroom shows how to put this into the calculators that you guys use, into the graphing calculators. But basically, I would handle what's under the square root part first, and then work with the rest of it. So someone grab your calculator and type in -4 times 1 times -256. Okay, so it's a positive 1024, right? Now do 8 squared minus 1024. Or sorry, plus 1024. Because we said it's positive. Okay, 1088. So we're going to now have -8 plus or minus the square root of 1088 all over 2. So now in your calculator, if you take the square root of 1088, you can do -8 plus that and then divided by 2. Or -8 minus that and then divided by 2. Now, when you do that, you should get one number that's positive and one number that's negative. We don't really want the negative number because we're dealing with measurements here, and we don't want to have a negative measurement. So does that make sense? Anybody else lost on that?
Yes, it's why they call it.
Okay, no one else has questions about how to do that? All right, we're going to look at number 18 on the worksheet then. Okay, so for number 18 on the worksheet, we have a tangent and a secant, right? So when we use that theorem that we had that we just looked at, we're going to have to do the square of the tangent. Okay, so the tangent here is 8. So we're going to have 8 squared. And that's going to be set equal to the outside part times the whole thing of the secant. So if you look here, these two segments are marked as congruent, right? So the outside part equals x, and then the whole thing equals 2x. You see it? So 8 squared is what? Okay, 64. And then what's x times 2x? X times 2x is going to be 2x squared. Okay. Make sense? So now we still have to solve for x. So the first thing we'll do is divide by 2. So what's 64 divided by 2? So we have 32 equals x squared. Now in order to get the x by itself, we're going to have to take the square root of both sides. And that will give you x. Okay, so for number 13, this is where we have the outside times the length of the whole thing equal to the outside of the other times the length of the whole thing. So if we look at this secant here, what's the outside measurement? And then what's the length of the whole thing? Okay, so the outside times the length of the whole thing is x plus 3, right? And now we're going to do that for the other one. So what's the outside of the other secant? And then the whole thing. So when we distribute this in here, 3 times x is 3x, and 3 times 3 is 9. And then 4 times 11 is 44. And then you're just going to solve for x. Does that make sense, Charlotte? Okay, Lily, hang on, let me pull that up. Okay, Lily, so for number 4, this is the same thing as what I just did on 13. Okay, so this is 2 secants, right? So when you're dealing with 2 secants, you do the outside times the length of the whole secant times the outside of the other one times the length of the whole secant. So the one that has 4 for the outside, what's the length of the whole length of it? Or the measure of the whole length of it? Okay, so the measure of the whole length on that side is x. So now on the other secant, the outside part is 5. So what's the measure of the whole length? Okay. So that's 18 because 5 plus 13 is 18. So now when you multiply that, you're going to have 4x equals, what's 5 times 18? So 4x equals 90. And then we'll just divide by 4 to get x by itself. Yep, 22.5. Does that make sense? Okay. Let's see, number 15 on the worksheet, Isabel. Yeah, round that up to the 10th though, okay? And then Thatcher, number 7. Number 7 is one where you have the tangent and the secant. So the tangent is squared. So your tangent is x. So you have x squared here, okay? And then it's the outside of the secant times the whole length of the secant. So the outside of the secant is 4. So what's the whole length of that secant? And then you just solve for x. So what's 4 times 16? And then, so you'll have x squared equals 64. And then if we need to get x by itself, we're going to have to take the square root of both sides, right? There you go. All right, Megan, number 23. What did you get? Yeah, you can turn it into a decimal answer. No, Thatcher, double check your math. Okay, so we'll talk through it, Megan. Let me pull it up. Okay, so 23 is a tangent and a secant. So which part is the tangent? So we're going to start out with 13 squared, right? Now on the secant part of it, we have the outside times the whole thing. So what's the outside part of it? And then what's the length of the whole secant? 5x plus 9. Okay, so 13 squared is 169. And then 5x times 5x plus 9. So we're going to distribute this 5x in. So 5x times 5x is 25x squared. And then 5x times 9 is positive 45x. Okay? Did you get there so far? Okay. So now we can't really do anything with it like it is. We need to bring that 169 over to the other side. Okay, so instead of, since we're adding 169, we'll subtract 169 from both sides. So I'm going to jump down here, and we're going to have 25x squared plus 45x minus 169 is equal to 0. Now, this is one we do have to do the quadratic formula with. So what's our a in that formula or in that equation? Okay, the a is 25. What's b? And what's c? Negative 169. Okay, so a is 25, b 45, and c is negative 169. So now, when we plug into the quadratic formula, we're going to have negative b. So our b is 45, so we're going to have negative 45 plus or minus the square root of b squared, which is 45 squared, minus 4 times 1 times negative 169, because that's your c. Or sorry, it's not times 1, it's times 25 here. Because it's your a is 25. Okay. And then that's going to be all divided by 2 times a, which is 2 times 25. Is that how you set it up? Okay. This is number 23. So working through now, here's how you'll do the part that's under the square root, because we'll deal with that first. So in your calculator, do negative 4 times 25 times negative 169. And then now do 45 squared minus that. Or, sorry, plus that, because it's plus, it's positive. Okay, now you can, so I would hold on to that number just because it's easier than what the square root of that number is. Okay, so on the outside, you've got negative 45. So do negative 45 plus the square root of 18,925, and then hit enter, and then do that divided by 2. Oh, sorry. Not 2. Divide it by 50 because 2 times 25 is 50. Did you divide it by 50 or by 2? I feel like maybe it didn't go through correctly. Okay. So yeah, there you go. 1.9. Now, that's okay. So if you do it the other way now, then you'll come up with the negative number. And in this case, we don't want the negative because we can't have a negative measurement. Does that make sense? All right, Campbell. So that's fine. I know you were having problems with it. I just wanted to know who I was talking to. So you need help with 15, 24, and 25. Let me pull up 15. You need the quadratic formula for 15, 19, 23, and 24, it looks like. Okay, so for 15, this is one where you have 2 secants. So you've got the outside times the whole thing equal the outside times the whole thing. So the outside of that top secant is what? And then what's the whole secant for that one? Not 10x because you're adding those parts together. So look, on that bottom secant, your length, your outside part is 8 and your inside part is 8. So that whole length is 16, right? So I know when we see a variable and a number, it's easy for our brain to jump to saying 10x, but it should be 10 plus x. So you're going to have x times 10 plus x equals 8 times 16. And then you'll have to distribute the x in on the left. So you'd have x squared plus 10x equals 128. Okay? And then that you'll have to plug into the quadratic formula. (24) is going to be handled the same way. Remember, you have to look at the outside and then the length of the whole thing. Is that probably what tripped you up on it? Okay. And then 25. (25) walks you step by step through what you need to do. So if we look at 25, the first thing it tells you to do is to find AB. Well, when we look at that diagram, is the length of AB already labeled? Okay. And then same thing for B, AC and AD. You can figure those two out, right? Okay. So then for C, it tells you to use AB, AC, and AD to find the length of EA. So when you use, when you look at this circle, you have two chords, right? So you're going to do part of the chord times part of the chord equal to this part of the chord times this part of the chord. We'll call this part that we're solving for X. Does that make sense? Yeah, Thatcher, that's right. So then for part D, Campbell, you're supposed to find EB. So you can find EB once you find EA because you already know AB. And then to find the length of the radius, EO, you know the whole length of that diameter. So can you figure out the radius from that? So there you go. Which part of it don't you understand, Lily? Okay, so the picture for 25 looks like numbers 1, 2, and 3, right? Flip over and look at the front of the worksheet. So how did we solve those? You remember we had to take the two parts of that chord, multiply them together, and set that equal to the two parts of the other chord. So for this one, if you got part A and B, label your picture, make sure and label your picture, and then you should be able to work out C. So Charlotte Ann, when you have a quadratic equation in standard form, the standard form is ax squared plus bx plus c equals 0. Okay, so your formula, your quadratic formula starts with negative b plus or minus the square root of b squared, blah, 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 right? So if your b in your equation, when it's in that form, is positive, then what you're doing with it over here is you're saying, okay, well, my formula is negative and then it's a b. So I'm just going to put that number in. But if your b here is negative, if it's like negative bx, so say it's like negative 5, then in your formula, it's negative b. So you would be saying like negative negative 5, which would make that a positive 5. Does that make sense? Okay. Lily, did you get part C? Okay, so look up here. It tells you that the whole length there is 160. And we know that if we know that EB is a diameter, it goes through the center of the circle, right? So since we know it goes through the center here at point O, that tells us that these two segments of that chord are congruent. So you'll be able to take that 160 and divide it by 2. Does that make sense now, Lily? Charlotte Ann, that's not right for number 19. So Lily, do you need help with D? Or are you good from there? Okay. We're just about out of time. Anybody else have questions? So close, Charlotte Ann. What's under your square root? Okay, that's where you got off some. Okay. So you should have 7 times 13 is equal to x times x plus 4. Okay. And then go from there. Devin, for 17 and 18. So 18 is going to be one that you have to use the quadratic. No, maybe you don't. I said that a while ago too. 18 is one you don't have to use the quadratic formula for, but I worked it out earlier in the video. So here in just a minute, grab the link off of your lesson plans and go back and kind of skim through the video to get to where I worked out number 18. For 17, you've got to take the square of the tangent part, and the tangent part of that is 12. Okay, so you're going to have 12 squared, and that's going to be set up equal to the secant, so the outside of the secant times the whole length of the secant. So the outside of that secant is x, and the whole length is 16. So you're going to do 12 squared is equal to x times 16. No, Thatcher, that's not the answer. Hey, here's the link to the YouTube video for MathLab, okay? So, Charlotte Ann, what's your A on the equation? And your B? And your C? Okay, your C is negative 91. So under your square root, you're going to have 4 squared minus 4 times 1 times negative 91. Yes, Thatcher. Okay, guys, I got to go get my kids off the bus. If you have more questions, just shoot me an email, okay? See you tomorrow.